Welcome to our presentation. We're here on behalf of the Young Professionals in Transportation for their Meet and Greet March, and we are Highway and Bridge Engineers at STV.
Hello, everybody. My name is Troy Ludlow. I am a highway design engineer here at STV. I graduated Drexel University in 2017, where I completed 3 internships as construction inspector and also a highway design technician. After that, I went on to receive my PE, and now I work as a highway design engineer here at STV.
My name is Christina Wilson. I graduated from the University of Vermont in 2014. My first job out of college, I started at a company that had something called a rotational engineer program, and they spent the first year of my career rotating me every 3 months to different departments throughout the country. This is a great learning experience, and I got to see a bunch of different things. I did a rotation in utility locating. I did a rotation in construction services. I did one in bridge design, and I was out in the field for my last rotation doing inspection work. After the year was up, I got to choose where I wanted to land, and I ended up choosing bridge engineering / contractor support. What this is a different branch of engineering that I didn't know a lot about in school, but basically we would design all of the temporary works that went along with building a bridge. This would include things such as temporary retaining walls or shoring walls, temporary towers to assist with the building of the bridge, as well as we would design formwork and false work for pouring concrete. We also would do bridge erection designs, so we would determine crane capacities needed to lift each member of the bridge, the stability of the bridge, both while it's being picked and in the temporary conditions as you're setting the pieces down, and pick weights, rigging, etc. We'd also do things like barge analysis, basically anything that needed to be done to help build the bridge. We did this in combination with designing the bridges themselves to help strengthen our relationship with the contractors, and then we would partner together to pursue larger bridge projects. So I kind of got a little bit of both worlds, got to see some interesting things being built, and this involved a lot of field visits, which was super helpful to my career. After that, I spent about 8 years in that career, and it was pretty exhausting because it's a very fast-paced environment. So I made a switch to STV, where I now do only bridge design work and have a little bit slower pace.
So the next thing we want to do is kind of describe the day-to-day life of a highway / bridge engineer. The first thing I'll mention is the workload coordination that goes into the job. So as you progress in your career, you're going to take on jobs, you're going to be working on multiple jobs, and you're going to be working as a part of a team. So in order to do so effectively, it's important to communicate with other members of your team to figure out who's going to work on what, when you're going to get it done, and what your deadlines are. So as part of our job here at STV, every week we have a weekly workload meeting where we all kind of get in the conference room, go around the room, everybody talks about when they're going to be in and what they're going to be doing, and that helps you to see who's available for immediate tasks if something comes up later in the week that you need done. And it also just helps you get familiar with the other projects that your team is working on. The next thing is assisting on the design projects. As you start, you're going to be doing probably a lot of calculations, a lot of plan prep, but as you progress in your career, you're going to get more involved in the design and actual implementation of your plans. Another big part of this is helping out other team members on projects that you're not necessarily assigned to. It's important to maintain your work that you are assigned, but also be available for your coworkers if they need help or assistance with something. Maybe they just need another set of eyes on a project, and you can lend them a quick hand. So it's important to maintain that team environment and help out people that need your help. And then the last thing I'll talk about is keeping track of your billable hours. So as part of in being a roadway engineer, you're going to be working on multiple different jobs at once for different clients, and the way that engineers make money for their company is by essentially giving their time. And so the client expects that you accurately report how many hours you spend on a job, because that's how they determine how much they're going to pay you. So it's important to be mindful of how much time you're spending on project A versus project B, and to accurately keep that time. So next thing I'll talk about is setting goals. As you're getting through your graduation, you're starting your career as an engineer. The first thing you'll have to do is start small. Think of small goals that you want to set for yourself. Obviously, probably the most important one or important goals is getting your EIT and your professional engineering license. These are going to be very important for you. They're pretty much the first stepping stone for you to get. So that'll be your first goal, and then you can start thinking about other professional certifications you want to get. And then the next thing is joining engineering societies. Because you're here listening to this presentation, I can already tell that you're part of the YPT, which is a great engineering society. There are also other engineering societies that are more focused maybe in your discipline or more broad, such as the American Society of Civil Engineers, ASCE, or the American Society of Highway Engineers, which is ASH. Getting involved in as many societies as you can is very important, and it's a good way to network with other peers, where you can learn about other projects. You can kind of see what other challenges other engineers are encountering, and maybe you get a chance to find out about a job that you didn't even know existed, or position at a new place that's just opening up. So networking is very important. And then the last thing I'll mention with your starting small is deciding on whether or not you want to continue your education. As engineers, we're going to be learning for the rest of our careers and the rest of our lives. So it's important for you to understand what you want to learn, what your goals are as far as education, whether that be getting a graduate degree or taking trainings, professional trainings. That kind of stuff is very important, and that's really going to help you in your career and help set you apart. So continuing education is a very important goal for you to set for yourself. And then as you move on in your career and you've kind of accomplished some of these goals, you'll want to expand them. The first thing that comes to mind for me is, determining if you want to specialize in one specific aspect of your field or if you want to expand your expertise. I've known engineers that are very good at one aspect of roadway design, whether that be geometry or traffic control or erosion and sedimentation pollution control. I've known people who are very niche and they know everything about one specific aspect of highway engineering. But I've also known engineers who are kind of more of a jack of all trades. They can do everything when it comes to highway engineering. There's room for both of those type of engineers on a lot of teams. So figure out what you want, and then that will help you progress in your career. And then again, you want to network with people in similar fields. It's going to help you to understand which direction you want to take your career, and it's going to help you to understand how other people solve problems that you might be encountering. So now we'll move on to a technical example, something that's loosely based on a project that Christina and I are working on right now. In this example, we've got an existing 2-lane bridge carrying a state route over a township road. As part of the proposed improvements, the Department of Transportation has informed us that they want to widen this to be a 4-lane bridge where they have 2 lanes of traffic in each direction. And so what we're tasked with is figuring out how to make that work while still maintaining the required underclearance under the bridge along Township Road of 16.5 feet. And another challenge that is included in this project is the adjacent wetlands, which you can see in the plan view. The wetlands are on the top right. We want to make sure that we're staying out of those wetlands as much as possible to reduce our environmental impact. So the first step really in this, and the real driving factor, is going to be the structural design. As you'll find out, the structural design is the most costly aspect of most roadway designs. So we want to get that cemented first before we start progressing with the rest of the roadway.
As Troy said, first you'll come to do some structural design considerations. So in our imaginary scenario here, our existing girder depth is 52 inches. So we're going to take that information, we're going to lay out where our new girders are going to lie and determine an approximate beam spacing. From that, we can determine how thick our deck needs to be for that beam spacing, and we can use that to calculate some loads and calculate a preliminary minimum girder depth in order for him to be able to maximize his vertical clearance. So say I run this imaginary scenario, I run these girders, I get to use modern day steel where the old girders used a less strong steel, and I can come up with a proposed girder depth that's 48 inches, so a few inches shorter than he had before. So then I would pass this back.
So with that information, we will start essentially laying out alternatives for these for the proposed widening. So the first alternative, alternative A, is going to be split widening, where we widen the road to the north, widen the road to the south, maintain the same center line of the road. As you can see in this plan view, it does mean that we're going to be closer to those wetlands. We're still out of the wetlands, but the adjacent grading of the roadway is going to be tricky to tie in before we impact those wetlands. There are things we can do with retaining walls or specialized grading in this area. So this is an alternative that is possible. And additionally, we provide the required 16.5 foot of vertical clearance along the township road. So this is a viable alternative, but we want to explore other alternatives to see what else is possible. The next one, alternative B, is widening only to the north. And in this scenario, you can see we are greatly impacting those wetlands. We are overlapping pretty significantly, and that's not something that we can take care of with just a retaining wall or grading. Typically, we try to avoid messing with environmental features as much as possible, including wetlands, because they require a lot of permits and they will require remediation in other locations. So we usually try to avoid this scenario. So we're going to shelve this alternative for now. And the last alternative, alternative C, is widening only to the south. As you can see, we've got a lot of clearance between our roadway and the wetlands, so we can confidently say that we're not going to be impacting that. However, because we are widening so far to the south and the township road profile is ascending as we move down along the baseline, we are no longer able to provide that 16.5 feet of vertical clearance. Because of that, we're going to have to get rid of this alternative as well. And so with that, in that analysis, we can land on alternative A. We do have a potential conflict with the wetlands, but it's much less than in alternative B, and we are providing adequate underclearance over the township road as we weren't in alternative C. So with these three alternatives, we've landed on alternative A. And now we can move on to designing the road. So the next steps are going to include filling out the road, making sure that we account for all of the vertical and horizontal alignments, making sure that we're meeting all of our criteria there. And then with that, we will then move on to things like guide rail layout, roadside protection. Usually that includes some combination of guide rail and structural barrier. And finally, we'll move on to surface modeling, which, as you can see here in the top right, this is a snapshot of a program that we use called Inroads, where essentially we create a template of what we want the roadway to look like in cross-section view, and then we'll apply that cross-section template to the baseline and create a 3D surface of the roadway.
And to go into some of the structural next steps, after we have decided on our alternative, we will start to finalize some of those preliminary numbers. So we'll determine in a final setting our required deck thickness based on our girder spacing. Then we will determine a finalized girder size, and we'll proceed from the top down to design the concrete pier, the columns, and the footings. Throughout that design, we'll design both the geometry of each of those items with the concrete as well as all of the rebar sizes and spacings for each element. After we get down to the bottom there, we'll see the piles, and we will calculate the loads that are on those piles so that we can communicate that with a geotechnical engineer who can run their analysis and tell us if we have sufficient soil capacities to support our bridge. This here is just to show you some of the steps that we would take during that process. We would use a variety of computer programs as well as some hand calculations that we will run a model and designs for each of those elements. So here is a CSI bridge model of a bridge, and you can see some of the stress distributions, and we'll use a combination of that with other things in our whole process. And this is just a quick slide. After we finish our design, we'll provide drawings of the bridge, all of the elements, to the contractors who are then going to go and build the bridge. So this is just a quick plan and elevation view of a construction bridge plan. With that, thank you for listening to us today. Good luck with all of your careers. If you have any questions for us, we look forward to meeting you at the meet and greet later this month. And here are our email addresses if you'd like to get in contact with us.
Thank you.